Hello, we are going to start the next section on solutions. What is solution? A homogeneous mixture of two or more components whose composition may be gradually changed by changing the relative amounts of the components. So what is this? This is a homogeneous mixture. Two or more components are there and composition can be changed. How? By changing the relative amount of the components. So this is the solution. It has two components generally. One is part is called solute, another part is called solvent. Now here you can have a mixture of solute, you can have a mixture of solvent also. Now solute is a substance that dissolves in the solvent, and solvent is the substance which allows one or more components to dissolve, that is one or more solutes to dissolve in it, and it is so called the medium of dissolution. It is not mandatory that in a solution you should always have a liquid as a solvent and solid as a solute. That we will see soon. Now you have three types of solution on the basis of the number of components. First is two component system, that is binary solution. Second is three component system, that is ternary solution, and four component system is quaternary solution. Now if you have salt crystals and water, you will get salt solution or saline water. Now salt crystals are solute, water is a solvent, and salt solution is a solution. Now you can see here water is a liquid and the nature of the solution, that is salt solution, is a liquid. So solvent is the component which exists in the same phase. Now you learn this new term, that is phase or state, that is either solid, liquid or gas, as the final solution. Now here if you have a gaseous one, you as a solution, this solvent should be gaseous. Okay, now there may be solute which may be solid also, or liquid droplets also. So now the solvent is the component which exists in the same phase or state as the final solution. Let us have some examples. If you take sugar and water, sugar is the solute and solid, water is the solvent and liquid, and you will get the sugar solution which is the solution and it is in liquid state. So here the liquid solvent and solution both are in same phase, that is liquid phase, whereas solute and the solvent, these are in different phase. So these components are in different phase. Now solute and solvent, these are in different physical state, but if solute and solvent are in same phase or state, the component that is in excess is called solvent. Here also, in case of solid and liquid, there also the component which is in more amount, that is called the solvent. So if solute and solvent are in the same phase or state, component that is in excess is called solvent. Examples of different types of solutions: liquid plus liquid, water and alcohol. Now solid plus liquid, there are enormous type of examples. You can see here the liquid is water. Now so these are called aqueous solution. This is the aqueous solution where the solvent is water. In case of alcohol as a solvent, the solution is called tincture. Or this is also in general non-aqueous solution. In non-aqueous solution you have some other material also, other solvents also there as a solvent. But if alcohol specifically, here I have mentioned ethanol, if methanol etc. is there, isopropyl alcohol, nowadays it is very common. So that is called non-aqueous solution. And iodine in ethanol, this is called tincture iodine. Iodine dissolves in ethanol. Otherwise any alcohol, then it is called tincture. There is liquid and gas, where liquid here is the solvent and gas is the solute. It is soda water. Most common in Coca-Cola and Thumbs Up, etc. Solid and solid. Now here whatever will be in more, that is called solvent. Now in case of brass, copper is in higher quantity. You can see from here, copper is in higher quantity, that is 70%. So copper is the solution here, and solid plus solid generally is called alloy. So solid solution is again a new term. It is the homogeneous solution of solid into another solid. Example, metal alloy, one is gold plus copper. Now gold is here generally solvent, and copper is in small quantity is mixed with gold. So it is the gold plus copper alloy. In case of brass, 70% copper is solvent and 30% zinc is the solute. Now come to the true solution. What is true solution? The solution in which the size of the solute particles is about 10 to the power minus 10 meter is called true solution. Okay, now here in true solution, solute molecules and solvent molecules are generally cannot be distinguished under microscope. In common use, we will generally use the term solution, which actually means true solution. We will use this term solution, which actually means true solution. So what are the characteristics of true solution or solution? It is homogeneous mixture. Solute particles are very small, that is 10 to the power minus 10 meter. Clear and transparent, doesn't scatter light. Components cannot be separated by filtration. You have to go for other options, let's say evaporation, distillation. Solute particles in solution do not settle down. Now what is dilute solution? Solution in which amount of solute is less compared to the mass of solvent is called dilute solution. Another term is there, concentrated solution. That is that the solution in which the amount of solute is rather more for a given mass of the solvent. So in case of dilute solution and concentrated solution, the percentage if you calculate, you will find the percentage of solvent in dilute solution is higher than the percentage of solvent in concentrated solution. Come to the saturated solution. Solution cannot dissolve any more of the solute at a given temperature. This is very important point. Given temperature is called saturated solution. So from this statement, it can easily be found out that any solution is dependent on the temperature. If temperature changes, nature of the solution can also change. So for mentioning any solution prepared, you have to mention the temperature. Now preparation of a saturated solution. Take 100 ml of distilled water, add 1 gram of nitre. Nitre is potassium nitrate, and stir it. It will dissolve. Then add another 1 gram of nitre. It also again stir, so it will also dissolve. Now continue adding 1 gram nitre at a time. Stir continuously. At certain time you will find no more nitre will dissolve at that temperature. This is very important, that is that temperature. This is very important. That temperature is very important. What is that temperature? That temperature is the room temperature. So while doing this experiment, check the room temperature. So at that temperature, no further solute will be dissolving in this 100 ml distilled water. So this will be called as the solubility, which we will be going through soon. So let's say 4 gram of nitre is dissolved in 100 ml distilled water at 25 degrees Celsius. It doesn't mean that if you increase the temperature, the 4 gram of nitre will be dissolved in 100 ml distilled water. It may happen that if you increase the temperature to 30 degrees Celsius, let's say, the solubility or gram of nitre dissolved in 100 ml may decrease also, or it may increase also. Now this solution, when this situation arises that no more nitre will dissolve at that temperature, this is called solution, saturated solution of nitre at that temperature. Remember this term, the temperature. You have to mention this temperature. This is very important. Now, so a solution is a homogeneous mixture. Again, this is a homogeneous mixture of solute in a solvent. Its composition may vary till a saturated solution is obtained. Again, the very important point is at a particular temperature. So a solution is a homogeneous mixture of a solute in a solvent. Its composition may vary till a saturated solution is obtained at a particular temperature. You best underline this point every time, that is particular temperature, at a fixed temperature. Any temperature, you can prepare a solution at 100 degrees Celsius, you can prepare a solution at -5 degrees Celsius, and you will get some different grams of solute is dissolved at different temperature. So at that temperature, that is a saturated solution. Now what is the effect of cooling on a saturated solution? Solubility of a solid decreases with fall in temperature. Very good example is while you prepare the sugar syrup at very high temperature. At high temperature, you can have a dissolution of sugar, and when you cool that sugar syrup, you will find some crystal of sugar has been deposited or precipitated on the sweet dish. So, if temperature of a saturated solution is lowered, or if the solution is left open at high temperature for longer period of time, the solvent vaporizes, part of the dissolved solute separates out in the form of crystal. So remaining solution is still a saturated solution, but at a lower temperature. Remaining solution means other than the other portion of the solution, other than the crystal which has been kept out. So now effect, so on cooling you will get some salts or the solute is separated out in the form of crystal. Next is effect of heating a saturated solution. If you heat a saturated solution, it will become unsaturated. Okay? Because why these things are happening? If you heat it, you will find some gap, intermolecular space between the liquid molecules increases. So if you have certain solution saturated at certain temperature, at that temperature it was saturated, but when you heat, there is a gap between or intermolecular space between the molecules that increases. So now it can accommodate more amount of solute, so it has become unsaturated. Similar thing can happen if you add more solvent. Now what is unsaturated solution? A solution in which more of the solute can be dissolved at a given temperature is known as unsaturated solution. Third term is supersaturated solution. It is a solution that holds more solute than it can theoretically do. If I calculate on paper, this much can be dissolved in this solution, but in practice you are seeing that the solution holds more solute, more of the solute than whatever you have calculated theoretically at certain temperature. That is called supersaturated solution. Now if you have saturated solution, heat, so it will become unsaturated. You have seen saturated solution, when heated it becomes unsaturated. Now there you dissolve more solute. Now cool down slowly. What will happen? The resultant solution holds more solute than saturated solution. Now this is called supersaturated solution, as it holds more solute than it can theoretically hold at that temperature. So a supersaturated solution at a particular temperature is one which is more concentrated, that is contains more solute than its saturated solution at that temperature. Means you have to compare both saturated and supersaturated solution at a particular temperature. So what is supersaturated solution? That is better stable, matlab it's between stability and instability. If you have slight disturbances or if you add certain solute crystal to the solution, it will make additional amount of solute to precipitate. So forming resulting saturated solution. Resulting solution saturated other than the crystal portion which is precipitated. Now it is possible to bring down the temperature of a saturated solution a little without the excess solute crystallizing out if there are no suspended impurities like dust particles are present in it. And second, the solution should not be disturbed physically. It is left standing still in its container. So you can bring down the temperature of a saturated solution a little without the excess solute to get crystallized. Now, it's a very important part but very easy part, that is concentration of a solution. Concentration of a solution is the amount of solute dissolved in a given quantity of that solution. You can express it in terms of mass percentage and volume percent. What is mass percent? Defined as the mass of solid solute in grams present in 100 gram of the solution. Mostly used when solute is solid and solvent is liquid. So the formula is mass of solute divided by mass of solution, that is solute plus solvent into 100. So if 10 gram of NaCl is added to 90 gram of water, the concentration of solution is 10%. What about volume percent? Defined as the volume of solute in milliliter present in 100 ml of solution. Mostly used when solute and solvent are liquids. So volume percent is equal to volume of solute divided by volume of solute plus volume of solvent into 100. If 30 ml alcohol is mixed with 70 ml water to get 100 ml solution, volume percent is given as 30%. You see the calculation over here. If you see the salt example, in the first one, alcohol was given as 2.5 liter, solution was 10 liter, and you can find out the solvent. Now volume percent is volume of solute divided by volume of solution into 100. Now volume of solute means volume of alcohol divided by the solution into 100. So 2.5 divided by 10 into 100, that is 25%. Second problem, sugar 50 gram, that is solute, water 2.45 kg, converted into gram, this is the solvent. So find out solution, which is solute plus solvent. So 50 plus 2450, that is 2500. So mass percentage solute divided by solution into 100. So 50 by 2500 into 100, that is 2%. Thank you. Thank you for your patience.